and thanks. So I'll share my my notes, which I've issued to all of you. I hope, have you received them? Or
Yep.
Good. The reason for issuing the notes, just to remind you, is that it gives you a bit of a reference to go back to if you need it. And I think having the videos is great. You can always look at those, but just having some notes on hand might be helpful. If you want to look at one particular thing that we have discussed, then the notes might get you there quicker than going back through the video to find one particular item that you're interested in. And I was just having a chat to Jelen before you other guys came. Yeah, these couple of first sessions are may seem a bit laborious or unexciting, if you like, but they're very important because Jelen's working on a job at the moment which I'm assisting him with, which requires exactly this process that we talked about last week, of looking at the NCC and then referring to the relevant Australian standards and working through that process to get the answers you need for the project. So that's a habit that we all need to get into, because that's a very important process. So today we're just going to go a little bit further down that track, and from next week on we start to get into some more exciting stuff, if you like. Start to talk about systems a bit more, and later on we're going to talk about water systems and those sorts of things, which personally is probably was my favourite thing to work on big projects. So we're going to do a few sessions on that. So I've changed the agenda a little bit. Whether or not you work on water systems doesn't matter. It's interesting and it's important to learn about this stuff, because sooner or later you're going to be involved in those sort of projects. So today we're talking about project references. Firstly, standards and design guides. There are many useful manuals, guides and standards available for application and reference when carrying out our design work. Some of you will be aware of these things, but I just want to go through it anyway in case you're not, and just to reinforce these references. Where Australian standards of reference in the NCC, compliance with these standards is mandatory, so you've got no choice, you have to use them. The list of Australian standards is quite long, and becoming familiar with them takes a fair bit of time, but it's important to be aware of the standards that govern our work. I've given a list of them here, which is not exhaustive, but there's some of the standards which are used often in our business, and awareness of their contents is recommended. Now, when I say that, all you got to do is grab the standard and have a look at the contents page. You don't need to read through the whole standard, just see what's in there. And, you know, there might be something that you remember when something comes up. Ah, yes, I know where to find that. So it's just being aware of what's there and making sure you refer to them when you need to. So that the standards highlighted in this list here are referenced in the NCC Schedule 4. So that means they're mandatory. Okay? The ones that aren't highlighted are not mandatory under the NCC, but they may be mandatory under other regulations. So just be careful. And in any case, if you can't find them referenced anywhere, it's best practice anyway to follow these guidelines, and we'll give you information if you're lacking that information. So AS 1668 Part 1, 2 and 4, we've talked about those last week. Everybody's aware of them. You use them every day. AS 1530 series, methods for fire tests on building materials, components and structures. This is the series of standards that deals with testing fire dampers, fire rating, And AS 1530 Part 4, for instance, is for fire rating. And as you go along through your careers, this will come up again and again. It's not that you have to refer to the standard, but you need to be aware of it because with fire-rated ductwork, it becomes very important. AS 1670 really deals with fire detection, warning, control, intercom systems, and is most relevant to the fire protection people. So it's not one that we need to refer to often, but you'll see it in the NCC again and again. Quite often, an electronic fire detection and alarm system is an option, as in smoke hazard management. Stephen Lamb is joining us.
Hello.
Or has joined us. Hello. Hi, Stephen. There you go.
Good.
Welcome. We've made a start. So we're just going through the notes, talking about standards at the moment. Have you got the notes there in front of you?
Yeah, I got it. Yes, I got it.
Yep. As I just again, I explained to the guys that these first couple of sessions are about setting the process of reference in place, I guess. It's very important. It's not the most exciting topic, but it is important for you to understand what references are important. After this session, we're going to get into some more interesting, involved stuff. But so we're talking about references today. AS 1677 Part 2, refrigerating systems. This also applies to obviously refrigeration systems for HVAC. And it's almost superseded. It's not gone yet, but there's a part of it that's still relevant, which is Part 2. I'll just skim down quickly. AS 5149, Part 1, 2 and 3 and 4, refrigerating systems and heat pumps. That's now the standard that's taking over from 1677. Now, if any of you have, well, I'm sure most of you, all of you have, worked on DX air conditioning systems. So these standards cover the requirements for those systems. And in particular, things like refrigeration, if you have a refrigeration leak, the allowable concentrations of refrigerant in spaces and how you deal with that. So that's something that's going to come up again and again when you're dealing with DX, or particularly VRF or VRV systems. We're going to talk about that next week in a bit more detail. 1682, fire dampers, fire and smoke dampers. AS 1735, lifts, escalators and moving walks. Okay, not really relevant to what we do. However, in that standard, there is a clause on lift motor rooms, and occasionally you'll be required to either air condition or ventilate a lift motor room. Okay, I don't know whether you've done that as yet, but it will come up on a project. And this AS 1735 tells you what you have to achieve with your system. Okay, so I'll leave it at that. I won't go into more detail, but if you're trying to work out how you work out the ventilation, it'll tell you in there. AS 1851 is routine service for fire protection systems. So that talks about the frequency of service of fire dampers or inspection of fire dampers and things like that that are involved in mechanical services. Just for your information, 20% of fire dampers have to be inspected every year. So that means within 5 years, every fire damper in a project has to have been inspected. And log books have to be kept. So the fire dampers are all numbered. Make sure when you're doing when the drawings are done that all these fire dampers are numbered. So you can. Morning, Kaushik. Morning. Can you hear us? He's talking, but no, your microphone's turned off. Anyway, we're working through the these standards at the moment, just briefly describing what's in them. AS2107, acoustics. Okay, it's not referenced in the NCC, but it's a useful document if you're working on a project and you're wondering what should be the design basis for the sound level of a particular area, say an office space, maybe a laboratory or whatever it may be, a hotel room. It's all in there, and it gives you a guide. A lot of projects have an acoustic report, and if that's the case, then you need to comply with the acoustic report for the project. I'll talk about that in a minute. But in the absence of that, AS2107 gives you some numbers to work with. Doesn't tell you how to design it. It just gives you a guide on what the target noise level should be. AS2243 series, now there's a number of them. I think when I last looked, there were about 10 different parts to this series. Safety in laboratories. So if you do a lab, everything you need to know pretty much is in there. There will be a design brief to go with it, but the governing standards are in that series of standards. AS2665 smoke and heat venting systems. This is not used very often, but it is an option in the NCC. If you've got a hot layer smoke exhaust system required, then quite often it'll say, or you can use a smoke and heat venting system. Now, I have done this in the past on large warehouses. Rather than have a smoke exhaust system with ductwork everywhere, you can use these smoke heat venting systems. And what they are is it's like a fire damper sitting on the roof of the building. You'll have several of them, and there'll be an array of them. And when there's a fire, they open up and they let the smoke vent straight out. So if you've got like a single level warehouse with a roof over it, which might be, say, 8 metres above the floor, these systems are quite good. They work automatically. There's no real control system involved. They just open automatically and let the smoke out. So it's an option. I put off-street parking in there because you all work on car park ventilation systems. And there is a bit of information in there about the allowable heights in car parks. Now, that's important because when you're trying to put ductwork in a car park, you need to know how high you can go with it, or what clearances you've got available to you. And this standard says that, don't quote me on this, but I think it says something like you must have a clearance of 2.3 metres or something like that. So this makes it's always a bit difficult with car park ventilation systems to have enough height to get the ductwork in. So just be aware of that. AS3000 wiring rules, not something that we work with directly, but obviously there's wiring of all our projects. So those rules govern the wiring that's done. It's usually done by, well, for the contractors, it's usually done by subcontractors. For the consulting engineers, well, you've got to design that in your office. Your electrical engineers would be designing the electrical systems in accordance with these standards. AS3500 plumbing and drainage. It's really for hydraulics, but there's things in there that affect mechanical as well. AS3666 part 1 and 2 is important for my microbial control. We've got drains and we've got cleaning of systems and keeping air conditioning systems clean. That's all covered under this standard. Pressure piping, well, yes, you don't really need it, but I'll just put it in there. 4254 part 1 and 2, these are important. Ductwork for air handling systems in buildings. Part 1, I think, is for rigid ductwork, so metal ductwork. Part 2 is for flexible ductwork. That's worth getting familiar with. You need to be aware of what's in there. Flexible ductwork, it also gives you instructions or guidelines on how flexible ductwork is to be installed. This is quite often a common problem with any building. When the flexible ductwork is installed, sometimes it gets squashed. Okay, when they're trying to fit everything into the ceiling, above the ceiling space, unfortunately, the flexible ductwork tends sometimes to get squashed. And if you've got no air coming out of an air outlet when you're trying to commission the system, it could be the flex that's been squashed, because if it's squashed, the air's not going to come out. So the standard says how it should be installed, and when you're looking around the job sites, have a look at that. Make sure that if it's not installed correctly, that it's fixed up, because you'll have a problem later. I've mentioned 5149. 5601.1 is for gas installations. So if you've got a job with gas, hot water heaters in particular, this standard tells you how that has to be done. And in our case, particularly with ventilation, it gives you the details on what ventilation is required for supply and exhaust of boiler rooms and so on. Any questions so far? Okay. Design guides. AIRA, Australian Institute of Refrigeration, Air Conditioning and Heating, produces many useful guides which can assist us regularly. Now, I think the MEPEC guys are aware of this. The other guys may or may not be. AIRA is obviously an Australian organisation, the authority in Australia on HVAC systems. The AIRA DA, or Design Application Series, provides detailed information on a wide range of relevant topics in our industry. It's worth looking through the list and procuring some or all of these to assist with your work. Perhaps your employer would invest in the series for your library. I know at MEPEC we have these online. Our guys use them. I'll just show you. So these are some of the guides: centrifugal pumps, noise control, ductwork for air conditioning, air system balancing, and so on and so on. So you can everyone see that? DA09, for instance, is air conditioning load estimation and psychrometrics. If you're doing a manual heat load, everything you need is in this manual. Okay, I know we don't do manual heat loads anymore, but if you really want to get the background on the heat loads, it's all there. And even sometimes when you're looking for, say you've got an internal load that you're not sure what you should allow, say something electrical in the space that you need to allow, put a heat load for, well, you'll find it in there. You'll find very detailed information on psychrometrics. So that's a good one to have a look at. But all of these, they give you detailed information on how systems are designed and best practice. So be aware of those. You can, if you join AIRA, I'll just keep going. Air filters, that's important. Air conditioning, water piping, how to size pipe work, what sort of pipe to use, cooling towers, water treatment, hydronic system balancing, that's for water systems, indoor air quality. So there's a wealth of information there that is available. You can buy those standards online. And you can, I'm just trying to think, I think if you're a member of AIRA, you may have access to those online. I'm not sure, but membership of AIRA is a good idea. So the AIRA Technical Handbook is another essential resource to use on a regular basis. Again, wealth of information on many topics, as well as things like conversion factors, charts, equations that we use often. So heat transfer equations, cooling load check figures, psychrometric chart. I'll just show you some of those. So this is just an excerpt of, sorry, I'll show you this one, Aerotechnical Handbook. That's the 5th edition. We're actually up to the 6th edition now, which I don't have, but that's what the 5th one looks like. And in here, there's pretty much everything you need to look at. So if you look at the topics, general information, there's equations, temperature scales, conversions, pump laws, fan laws, thermodynamics, design data, heat transfer, thermal properties, insulation when you're doing heat loads, U value calculations or typical building materials, air distribution systems, duct sizing, duct system pressure losses for doing the fan static calculations, pipe systems, and so on and so on. There's lots of information, so that's worth having. I've just picked a few of these things out that you'll probably start to use a lot if you're doing heat loads. Air heat transfer, latent heat. Does everyone know what latent heat means? Good. We're going to talk about that more in the next couple of sessions. So we'll go into that. Sensible heat. So latent heat is where there's moisture involved. Okay, there's a mass transfer, which brings with it a change in the relative humidity in the space. Sensible heat is based on a temperature difference and the total heat, which is the sum of sensible and latent. And there's lots of other things in there. Cooling load check figures. These can be useful at the start of a project if you're trying to get a feel for what the total load of the project might be. So you give it a new building and someone says, oh, what's the heat load likely to be? Well, you can have a look at this and say, well, it's probably going to be, let's say it's an apartment, the first one, about 120 watts a square metre. So straight away, before you start doing your heat loads, you can sort of get an estimate of what the load on the building is going to be, because this might help with your spatial allowances. For condensers, how big are the fan coil units going to be, etc., etc. It's all very helpful. If you do a shopping centre, it's really useful because at the start there'll always be a lot of preliminary work trying to work out the spatial requirements. Or an office building, same thing. The cafeteria, 350 watts per square metre. Clothing stores, and department stores, etc. So those sort of things are very handy. There's an office, general perimeter, 170 watts a square metre. General interior, 100 watts a square metre. A private office, 180, which would normally be on the perimeter of a building. So that makes some allowance for the external load from the sun and heat transfer through the building. Psychrometric chart. I guess you're all familiar with these. So that's in there as well as some description on what's in the psychrometric chart and what it's used for. And we're going to talk about that not next week, but the week after. We'll talk, and the week after that. So sessions 4 and 5, I think, are about heat loads and psychrometrics. So we're going to get into that a bit more. So, as I said here, membership of AIRA is strongly recommended. It's not very expensive, and they have regular meetings, so you can go along to those and listen to guest speakers who talk about relevant topics, as well as meeting people. You know, you meet other people in the industry, and you make some more friends, and you get to know people who are doing certain things, and it's all very helpful to expand your network within the industry. So it's worth joining. And also, if you join, you get a monthly journal with interesting articles in it, and they give you lots of other stuff as well. Every year they'll give you the technical handbook or the updated technical handbook. They'll give you references for the industry. So, you know, other suppliers, or service providers within the industry. They're all listed in this book that they give you every year, but you only get that if you remember. Okay. ASHRAE. I don't know if you've heard of ASHRAE. It's an American Society of Heating, Refrigerating and Air Conditioning Engineers. Now, when I started work a long time ago, ERA was just really getting started. Well, it had been around for quite a while, but it wasn't as well represented as it is today. So we used ASHRAE a lot when I started work, because ASHRAE's got everything. But in those days, it was in imperial units. So we had to be a bit bilingual between imperial units and SI units. And, you know, we didn't have computers when I started work. So our heat loads were done by hand using ASHRAE data. And their data was for the Northern Hemisphere. So you can imagine, we had lots of fun. We had information that was in the units that we weren't using in Australia, and it was in the Northern Hemisphere. So we had to swap it over to the Southern Hemisphere and make it all relevant. So doing heat loads was quite a laborious process, I can assure you. Today, you've got the benefit of using Camel, and I know there's a lot in Camel, there's a lot of data to put in, but I can assure you it's so much easier than doing it by hand. ASHRAE have 4 books, and I've mentioned down here that they are produced in SI units these days. You can get both. You can get the imperial units as well, but which the Americans still use, but obviously we use SI, so those books are available in those units. So there's refrigeration, fundamentals. Fundamentals goes through all the basic stuff you need to calculate heat loads. As it says, they're fundamentals for for us, you can find in ERA. Most of this fundamental stuff you'll find in ERA. HVAC systems and equipment, HVAC applications. Every year, the oldest book is updated. So it's a 4-year cycle. The HVAC applications will be updated this year. There'll be a new one out for 2023. As I said, there's information on these handbooks on everything that we do. Fortunately, the ERA guides and handbook cover just about everything we need, but there are times when reference to ASHRAE may be required or beneficial. For example, if you're working on a museum or an art gallery project or an archive store or something like that, design criteria may be based on ASHRAE guidelines. And I've done one of these not that long ago in Sydney before, when was it, 2018. We did a museum at University of Sydney, and the design criteria was based on the ASHRAE standard for museums and art galleries, and they give them a rating of A or AA. This museum was an AA, which brings in a lot of stringent requirements on temperature tolerances, pressures, pressure differentials, and so on. So it was a very interesting project, but we had to use the ASHRAE guide for that. You can join ASHRAE, and when you join, you get access to their resources. They have an excellent monthly journal, which, like the ERA journal for Australia, the ASHRAE journal has got a lot more in it than the ERA journal. It's a matter of how much spare time you've got to read all these stories, but and you can access a lot of stuff online as well, so you can have a look at that if you want to. A similar organisation to ASHRAE is CIBSE, which is the Chartered Institution of Building Services Engineers, British organisation. Produces many useful handbooks and design guides as well. They also have local chapters in Australia who run regular meetings in various locations. So, and there's one in Victoria, based in Melbourne. You may be aware that of their groups, that they have monthly meetings. They usually charge a small fee to attend, but if they're covering a topic that's of interest to you, it's worth going along. Once again, you learn something and you meet some other people. So you're building your network. The more you get out there and meet people, the better it is for you. And you might meet somebody who's working on something that you're working on yourself, and you can share a bit of information and help each other. That's what it's all about, meeting people who can share information. Commissioning guides produced by CIBSE are often referred to in specifications as a benchmark for balancing, commissioning and tuning, etc., particularly Green Star projects. So if you're on a Green Star project, you'll see reference to CIBSE guides. Just out of interest, if you're working with engineers from the UK or Ireland, quite often their qualifications or their undergraduate studies will be as a building services engineer. I don't know whether you've noticed that. Like in Australia, we're mechanical engineers generally who work in this industry. From the UK, they're usually building services engineers. So they've been through a different course to us because they've covered more than HVAC. They've looked at electrical systems, fire systems, and all those other systems that are involved. So they're generally not specialists in mechanical, but have a broader depth of knowledge. You can become a member of CIBSE, and it's probably worthwhile. But if you've got the time to attend their meetings and get involved with that. Next one I'll put in here. I did mention this last week, but I'll mention it again because it's quite helpful. The American Conference of Governmental Industrial Hygienists. So from time to time, we're involved in industrial projects which may involve processes like manufacturing, mining, welding, soldering, woodwork, dust collection, chemical vapor extraction, specialised exhaust hoods. There's all sorts of things. You might work on an automotive parts manufacturing facility, for instance. I've done a few of these where they have a lot of machines that are machining parts for cars, racing cars and things like that. They need some special exhaust for those machines. So AS 1668 Part 2 doesn't really go into that. It's more about occupied buildings. So this standard, which is that one there, it's available online. I downloaded it for free, which I was quite surprised that you could do that, but because back in the day when I was looking for this reference, the book, before we had computers, these books were like gold. If you could find somebody who had one of these books, make him your best friend, because they were hard to come by, but now you can download it. So you can see here, there's a lot in it, and there's basic design principles for ventilation systems, which is useful anyway. But you can find it in ERA, ASHRAE, but not the references to industrial ventilation systems. Well, ASHRAE would have it, definitely. You'd find it in there, but this is a really good book to have a look at. So a few other things that you'll come across: the Property Council of Australia guides. If you're working on office buildings, they have classifications for various quality levels of office accommodation. For instance, premium grade, A grade, B grade, C grade. And as you go down from premium grade, obviously the requirements are less onerous, if you like. Premium grade is the best. And you're really talking about Green Star level accommodation there. The Green Building Council of Australia give the requirements for Green Star ratings. You can do a course to become, well, you used to be able to, I'm not sure that that's still the case, but it probably would be, where you can become a Green Star accredited professional. Am I right in saying that you can still do that course? Has anyone looked into doing that? When Green Star first came out, pretty much anybody who was involved in designing HVAC systems was encouraged to get that accreditation. So I did it. But if you're working on Green Star projects, it's worth doing that so you understand all the requirements. It's quite involved. Neighbours is kind of a similar thing, but it's referring specifically to energy ratings. There are a few other state standards as well within the neighbours system, such as waste management and things like that. You'll see that come up, and it's included. Their energy ratings are included in the Green Star requirements. So be aware of that. For hospital projects, there's the VHHSBA engineering guidelines. Chock and I were talking about this the other day. If you're on a healthcare or hospital, well, I say hospital, but it could be any healthcare project, this sets out the design criteria for those projects. That's a Victorian one. There are others in different states. I think they're pretty much the same now. They used to be all very different, but now I think they're starting to standardise a bit across the country. I'll show you a spreadsheet that gives you some of their design criteria. Can you see that? See that spreadsheet okay? So as you can see, there's all these different spaces within healthcare or hospitals, pressure relationships, minimum outdoor air changes, minimum total air changes as per the supply air, all room air exhausted directly out to outdoors. That's a question, yes or no, basically. Air is circulated by means of room units, yes or no. Design humidity, design temperature range, noise levels, air filtration grades, and main purpose. So it's either air conditioning or infection control. Air filtration grades are important to comply with that. So, for instance, we were looking at procedure rooms and sterile stores. Let's see if I can find that. Sterilisation department, sterile storage room. The filters required for that, G4, F8, H14. What that means is in your air handling unit, you have a G4 panel filter, an F8 deep bed filter, and at the terminal, which is where the air comes into the room, at the grill on the ceiling, you need an H14, which is a HEPA filter. Operating theatres would be the same, similar sort of requirements. So that's a good one to refer to.
Sorry,
now,
Peter, do you get that online, that Excel file?
Yeah, that's a good question. I was just about to say that. Chock, do you know if you can download online? I think you probably can.
Yeah, it should be online.
Okay.
Because there are like 3 tables.
Right, cool. Thank you. I'll have a check.
As well as that spreadsheet, there is a design guide which is about 45 or 50 pages long. I can show you that, I think. Bear with me for a second. So this is the Engineering Guidelines for Healthcare Facilities, Volume 4, Heating, Ventilating and Air Conditioning. So in there's a lot of description about what you're required to do if you're working on a healthcare project. So if you've got a healthcare project, just make sure you understand what the design criteria for the project is. And in the absence of anything, this is what you should refer to. And tell your client that this is what you're referring to because this is an accepted standard. AS 1668 Part 2 does have a chapter on healthcare facilities, but there's not much in it. So you'll probably find if you're looking for something specific, it's not there. So you can refer to this guide to get the requirements. So, any other questions?
I have a quick question regarding design practices. So something similar to healthcare. Do we have anything for workshops. Say I'm working on a project which is like a technical school, and I got rooms which are having wood cuttings, weldings. So all those fumes. So is there a guideline or something I could look up to have an understanding on how to design it better? Like I got some project examples, but I'm just curious if there's
Yeah.
any references I can
Well,
look up to.
what I used to do, I'm not sure if there's an Australian standard. I don't think there is.
Okay.
Going back to that industrial guide. So this one, that covers all of that. And I've done those sort of projects. I've done TAFE colleges where they had woodworking, welding, soldering, all those sorts of things. I understand what it is that you're dealing with, and you'll find in here that there'll be something in there that will help you.
Yep. Sure.
I know it's an American standard, but I don't believe there's an Australian one, unless anybody else has come across one. I don't think there is.
Right. Cool. Thank you. Yep. I'll have
Have a
a
look
check at that.
I mean, I'm happy to share this with you, but it's a big document. It's I think if I tried to email it to you, it wouldn't get to you. So, but you'll be able to download it on that website that's on the notes.
Sure. Yep. Sure. I'll have a look at it. Thank you.
If you have any trouble, let me know and I'll try and help you get it. But it's a very big document. That's the only problem.
Yeah, I understand. Thank you. Thanks, Peter. I'll let you know how it goes.
Okay. Now, finally, I've just made some notes on project documents here, and I've mentioned this before as part of the process in the first stage, and I tend to be a bit repetitive. I'm trying to just make you aware and commit it to memory that there are things you need to look at. Okay. The majority of projects that we work on have a multitude of documents which define the requirements of the project and enable the design, construction, commissioning, operation and maintenance of the project. The design could be carried out by consulting engineers or contractors, so we've got representatives of both here. The project delivery contract may be construct only or design and construct. So construct only, we have talked about this before, but it's where the contractor tenders a project designed by somebody else, usually consulting engineers. And really they've just got to install what's been documented. There are some checks to be done, obviously, but basically you're not redesigning or trying to bring in some value management to the project. You just put in what's been asked. Design and construct is where it's designed by, well, it may be designed by somebody else, but a contractor has the responsibility of the design and the construction. So that gives a bit more scope to the contractors to change things if they see fit and if there's benefits for the project. In most HVAC contracts today, there's a requirement for the contractor to familiarise themselves and coordinate their work with all other building trades. Well, it's obviously, we have to coordinate with everyone, but it requires, particularly in a design and construct project, there is a requirement on the contractor to comply with everything in everyone's documents. It's quite onerous. So you need to be aware of all this information. So the list is probably longer than this, but it would include architectural drawings and specification. The only thing in there that probably is going to affect us is how the building is going to be built, what clearances are available, spatial provisions for mechanical. But there might be some information in there about the glazing to be used as well, which is important in the heat loads. And we'll talk about that in the next session or 2 sessions from now. There'll be a design brief or design criteria, mechanical drawings and specification, structural drawings, electrical services drawings, and spec, fire protection services, etc., etc., etc. There's usually these days a fire engineering report I mentioned this last week, and I think there was a question asked. If there's reference to mechanical services in the fire engineering report, then you need to comply with that. And that might be different to what is in the NCC or AS 1668 Part 1. But the fire engineer has the authority to come up with alternatives. Okay. Environmentally sustainable design report. There could be things in there that you need to comply with. NCC compliance report, Section J, well, you have to comply with Section J anyway. And the acoustic report, which I mentioned earlier, which might talk about noise levels in certain areas. Well, it will talk about required noise levels in different areas. It may go so far as giving you some guidelines on velocities for ductwork. Let's say you're doing something that's noise sensitive, like a sound studio or something like that. They might say that they want a noise level of, let's say, NR25, which is very low. And they'll say in order to achieve that, your supply air duct velocities need to be 4 meters a second or something like that. And they vary in the content that they give you. They might just say, we want NR25, and it's your responsibility to design the system to achieve that. So then you've got to do the acoustic analysis. So as for every project, compliance with the NCC and Australian standards is also required. So you might have conflicts between these things, between the NCC and the fire engineering report, for instance. Usually the fire engineering report will govern the project because they've issued a report which has been accepted by the building surveyor or building certifier, and that becomes the requirement for the project. So make yourself aware of the interfaces and coordination requirements with all the other parties to ensure the project is designed, constructed and commissioned as smoothly and efficiently as possible. That's the end of the notes. I hope that's been of interest and useful to you, but once again, we're just going through the grinding stage in these two, the first session and this one, but next week we'll get into some more, let's say, interesting stuff. But awareness of these standards and references is essential, and use them because they help you do your work. Don't sit there scratching your head thinking, how am I going to do this? You can pick up that standard, or one of those standards, or one of those references I've mentioned, and there'll be something that will help you. Or you can talk to your colleagues as well. But this information's available. It's very useful, and you'll find that you keep using it again and again. And nowadays it's so much easier that this stuff's available online, so you can just grab it when you need it. Back in the early days when we didn't have computers, we had to have books, and so and as you know, books are expensive, so we didn't always have the books we needed, and you'd be scrounging around trying to get information. So the internet's fantastic for that. So go and grab whatever you need. Any questions? No? Okay. Next week, we are talking about DX air conditioning systems. I know that some of you are already working on these systems and have had a fair bit of experience, but we're going back to the basics, which may or may not help you, but I hope it will. And some of you who haven't done much design on these systems will get benefit out of it. And then we're going on to talk about heat loads, and then and fan systems, and then water systems. So we're getting a bit deeper into the detail as we go along. And so appreciate your attendance, and look forward to seeing you again next week, unless you've got any other questions. So what I'll do on Thursday this week is issue the agenda for next week's meeting, which will be the notes. And I'll also issue the revised agenda, which has been changed. The dates haven't changed, it's just the content. And I said at the start that the content could change depending on the feedback that I'm getting from you guys, and what we think is probably relevant to you and beneficial. So that's happening. It's a moving target, and I'll try and keep it interesting and relevant for you. Okay, thank you.
Thank you.
Thank you.
See you soon.